Okay, for our next section here, we're going to be talking about polynomials and rational equations yet, but instead of dealing with equations, we're going to be talking about inequalities. What's an inequality? Do you guys remember? So an inequality, yeah, would be like less than or greater than, less than or equal to, or greater than or equal to, something like that, right? Okay, now in the past when we've talked about these and we've dealt with like interval notation, so that was like a certain way that we would write out our solutions. Do you remember what we used when we had less than or greater than, and what we used when we had the equal signs? Like when we wrote it out in interval notation, we kind of wrote those, like the answers together. Do you remember what we put on the outsides? Okay, so if you don't have an equal sign, you would put parentheses on either side, because that means you could go up to that number, but you can't have it actually equal the number. And then remember, when it has an equal sign, it's going to include that number that you're at. And so that's when we're going to have those hard brackets again. Okay, so we're still going to be writing some of our answers when we get into finding like our final solution. We're going to be writing our answers with kind of this notation here. Okay. So we're going to be talking about first with polynomials, how to solve a polynomial inequality, and then we're going to be graphing our solution on a number line. And we're really going to be doing that for all of these. It's just how we handle a polynomial is a little bit different than how we handle a rational equation. So when you're dealing with a polynomial inequality, you're going to solve that polynomial by trying to like factor it, or if you can't factor it, you might have to use other methods like quadratic formula or something to find your answers. I would say though, most of these that you're going to see, you should be able to factor. We're probably not going to throw you anything super crazy right now, just because we're trying to help you understand how this works. Okay, so we're going to solve and graph the solution set, and then we're going to also write our solution in that interval notation. So this first one that we're starting with says x squared minus x is greater than 20. Before you start, like even before we were doing these with quadratics, when we were spending time with just talking about how to factor and how to graph and all that, we always had to make sure that it was equal to 0. So you can see how step 1 says set equal to 0, and then we're going to solve it. So to solve for this one, to get it to equal 0, they had to move that 20 over. And so since it's positive, they did that by subtracting it. So they basically did like minus 20, minus 20. And they wrote it out like this: x squared minus x minus 20 now equals 0. And I'm going to kind of ignore the inequality for right now. I'm just going to focus on how would I solve this if it was just a regular equal sign. So I want to factor. So remember, when you're factoring for like this one, you're thinking of numbers that can multiply to negative 20 and can add to a negative 1. What two numbers can do that? And really watch your sign on this one. Right, you want negative 5 times 4, and you want negative 5 plus 4. Okay, so this is going to say x minus 5, x plus 4 when we factor it. But then we're still thinking about what happens if we set it equal to 0, because I'm looking for my solutions here. So if you set each of those quantities equal to 0, what are you really going to get for your x? Positive 5 and negative 4. Okay, so now what we're going to do is look at how this goes on to a number line. Okay, so we're going to put these 2 points, and they have those down here for you. They have negative 4 and they have positive 5 already put on the graph. Okay, now in the past, like when you guys were way back in Algebra 1 and you had to do problems like this, you just had like the dots there. You didn't worry about, are there parentheses or are there brackets? Okay, but we are going to maybe start to add that in on our graph as well, just to kind of really show like this interval notation is related to this stuff. Okay, so we've got a point at negative 4 and we've got a point at 5. Now we want to figure out, where do we shade in on our number line? So like, what set of numbers are good solutions for this polynomial? To do that, you have to check numbers that are inside of what they're going to call intervals to see which ones work and which ones don't work. Okay, so what I mean is, you want to pick a number that's smaller than negative 4, bigger than 5, and you want to check a number in between them to see if it works or not for your equation. So remember, we're taking all of these and we're going back to this equation, like either here or you can use this one. It doesn't really matter which one you use when you're testing. okay? So I would start by testing a number that's in between them. And if I can, I'm going to use 0 because 0 is easy to work with. It doesn't require a lot of thinking, especially when you're multiplying and adding and stuff, okay? So I'm going to start by testing 0. I'm going to plug it back in up here to this equation. So the x squared minus x is greater than 20. If I do 0 squared minus 0 greater than 20, I'm going to get 0 is bigger than 20. Is that true or is that false? That's false, okay? Which means I don't want to use 0. 0 is no good to me. So I just put a little x here in the middle of the graph to say 0 doesn't work. What that also tells you, though, then, is that all those other numbers in between -4 and 5 aren't going to work either. 1, 2, 3, 4, -1, -2, -3, none of those are going to work. Okay, so none of that is going to be used, which means my solution set is probably going to be on either side of 5 and -4. But we still want to make sure that we're testing all of our intervals. We want to just be diligent and make sure that we don't have something crazy happen here where actually nothing works and there's really no solution to the problem, or something kind of bizarre can happen every once in a while. So we just want to make sure that we test all of our intervals. So I'm going to test another one. I'm going to now do something bigger than 5. So I'm going to test 6. Okay, I'm going to put it up here where I've got a little bit more room. So I'm going to test x equals 6. So I'm going to put it back up in that original equation. So 6 squared minus 6 greater than 20. And you can use a calculator to help you. You can do this mentally if you need to, but this would be 36 minus 6, which is 30. Is 30 greater than 20? Yes, this is true, which means I do want to shade on this side of 5. Okay, so I'm going to go ahead and shade like this, or kind of color that side of the graph in. And it's going to keep going. Like everything bigger than 5 is going to work. Okay. Then the other thing is to test -4. So a number smaller than -4 would be like -5. So if I put in a -5 for x, that would look like this: -5 squared minus -5. Really watch your signs on these ones. That's why I'm putting parentheses around all my numbers. This would become 25, and then this becomes +5. So we get 30 again, which is still greater than 20. So this is still true, which means I want to shade on this side as well. Okay, we all clear on how to find how we shade. All right, now the only other thing that I would maybe want is this notation, okay? Now, if you come back up here to our equation, notice how it had just a greater than sign. All of these had greater than signs. Are there any equal signs here? No, which means at -4, there'd be like parentheses, and at 5, there would be parentheses. There's not going to be brackets on this number line because there's not an equal sign with my inequality. So down here, they're writing it in that interval notation. Now let's see what they wrote. They're saying that anything that's -infinity up to -4 works, which is what we had shaded in red on our number line. And then on the other side, they're saying anything from 5 and bigger works too. So that's why they're using those infinities, because it's going to go forever to the right and forever to the left. Okay, and again, the parentheses are being used because we don't have an equal sign with our inequality. Okay, so let's try one from scratch here. So we've got x squared plus 8x is less than 9. Let's first rewrite this so that it says equal to 0. So I'm going to move that 9 over. So it looks like this now. Okay, I want you guys to factor that. What are two numbers that multiply to -9 and add to 8? Okay, +9, -1. So if you set those equal to 0, what do you get? Good, -9 and +1. All right. So now let's put this on the number line. So I'm just going to sketch a number line over here. It doesn't have to be, crazy detailed. I just want to see these numbers. So I'm going to put -9 and 1. I don't really care about what's going on in the middle. All right. Now, these are my solutions. I'm just going to put a dot on either one, but now I need to test some points. So I'm going to give you a little bit of time here, but let's maybe write down what numbers we're going to be testing. So what's a number that's in between -9 and 1 that would be easy? Good, 0. I like 0. How about a number that's bigger than 1? Yeah, you could just do 2. You don't have to be crazy. And anything less than negative 9? Okay, negative 10. So you're going to plug these 3 values in. I would just go back to your original equation, plug it into that. I'll give you a couple minutes. I want you guys to do that. I want you to test all 3 of those and see if you can figure out where we would shade on our number line. Okay, let's take a look here. We tested 0, and this is true. And these other 2 were false, right? So that means 0 works, which means I want to shade in between these 2. So I'm just going to kind of color on the middle of my number line there. And then did I have brackets or parentheses? Okay, parentheses. Now make sure this time you draw them in like this, because they would be on either side of that shading, because we're kind of holding all of this stuff in the middle together with those parentheses. Now let's think about how we would write this interval notation. How would you write this with the correct like numbers and symbols? Okay, we know we have parentheses. Do we include negative infinity? No. Where are your solution sets at here? Yes, in between negative 9 and 1. Okay, so we're going to have parenthesis negative 9, comma 1 for this one. That's all you need to write this time for your interval notation, because it is stuck between those 2 values. It's not going to go forever to the left or forever to the right. It's stuck in between those 2 numbers that we found. Okay, so that's how you're going to work with these polynomials. Okay, you're going to be factoring, putting them on a number line, and then solving them.